students, let us solve some problems based on the topic triangles from class 9th. The first question is, in triangle PQR, measure of angle Q is equal to 90 degree, PQ is equal to 12, QR is equal to 5 and QS is the median. The question is, find the length of segment QS. Now to solve this we need a diagram. So let us draw a triangle PQR where the measure of angle Q is 90 degree. That means angle PQR is a right angle given. Length of PQ is given, length of QR is given, and it is given that QS is the median of a triangle. As QS is a median, S must be the midpoint of side PR, which is the hypotenuse in this triangle PQR. So we start with the given in triangle PQR. It is given that angle Q is 90 degree. That's why triangle PQR is a right angle triangle. And in that we can use the Pythagoras theorem. By that we can write hypotenuse square is equal to side 1 square plus side 2 square. Hypotenuse over here is PR. So we should have PR square that is equal to two sides which makes right angle are PQ and QR. That's why we should have PR square is equal to PQ square plus QR square. Now here the lengths of PQ and QR are given to be 12 and 5. So we should replace PQ by 12 and QR by 5 to get 12 square plus 5 square, that is equal to PR square. 12 square is 144 and 5 square is 25. So 144 plus 25, that's 169 is equal to PR square. We have to find the length of PR. That's why we should take square root on both the sides. So square root of PR square is PR and square root of 169 is 13. So this is the length of PR. But we are asked to find the length of segment QS. Now here, segment QS is a median given which is drawn on the hypotenuse of this right angle triangle. And we have one property of the length of median drawn on the hypotenuse, that is the length of the median drawn on the hypotenuse in a right angle triangle is half of the hypotenuse. Its QS is equal to half of hypotenuse PR, and this is because the median drawn on the hypotenuse. Now we have just found the length of PR to be 13, so we'll replace PR here by 13 to get 1/2 into 13. So if we divide 13 by 2 here, we get QS is equal to 6.5. That is the length of segment QS is 6.5. Let us solve the next problem. The question is based on the diagram given. In this diagram, triangle ABC and triangle DBC, these two triangles are given. Question is, find the values of X and Y using the information given in this diagram. And also we have to find the measure of angle ABD and the measure of angle ACD. First of all, let us find values of X and Y. For that one, let us consider triangle ABC. In this triangle, sides AB and AC are denoted by equal symbols. That's why these two sides are congruent. And we know that if in a triangle two sides are congruent, then angles opposite to them are also congruent. So angles opposite to side AB and side AC are angle ABC and angle ACB. And this is because by isosceles triangle theorem. Here measure of angle ABC is denoted by letter X and measure of angle ACB is 50 degree. So we should have here measure of angle ABC, that's X, is equal to 50 degree. Measure of angle ACB is 50 degree, that's why X is equal to 50 degree. In the same way, we can have for triangle DBC. In this triangle also, side BD and side DC are congruent. That's why angles opposite to them are also congruent. This angle DBC is congruent to angle DCB by isosceles triangle theorem. Measure of angle DBC is given to be 60, so we'll replace angle DBC by 60, and measure of angle DCB is denoted by letter Y. That's why it is replaced by Y. To get the value of Y is equal to 60 degree. So this is the answer of the first question, that is we have found the values of variable X and Y. Now we have to find the measure of angle ABD. Now as we can see in the diagram, angle ABD is formed by two smaller angles, that is angle ABC and angle DBC. So if we add these two angles, we get angle ABD. That is angle ABD is equal to angle ABC plus angle DBC. Measure of angle ABC, that is X, we have found the value of X to be 50 degree. That's why we replace here angle ABC by 50 degree plus measure of angle DBC. It's given to be 60 degree. That's why 50 degree plus 60 degree, that is equal to 110 degree. So this is the measure of angle ABD. In the same way, Measure of angle ACD is also found by adding two smaller angles, angle ACB and angle DCB. So angle ACD is equal to angle ACB plus angle DCB. Measure of angle ACB, it's given to be 50 degree. So we'll replace here. And measure of angle DCB is Y, and the value of Y is 60 degree. That's why measure of angle DCB is 60 degree. 50 degree plus 60 degree, it would be 110 degree. So measure of angle ACD is also 110 degree. Let us have the next question. The length of hypotenuse of a right angled triangle is 15. Find the length of median of its hypotenuse. So first of all, let us have a diagram. So let us consider this as a right angled triangle. We'll name this as triangle ABC, where the measure of angle B is 90 degree. Now it is given that the length of the hypotenuse is 15. So in this triangle, if angle ABC is right angle, and side opposite to it, that is AC, is the hypotenuse. Now we have to find the length of median drawn on the hypotenuse. So from vertex B, we have to draw a median. We'll name this median as BD. So we have to find the length of segment BD. For this triangle, as BD is the median drawn on the hypotenuse, by the property of median drawn on the hypotenuse, we have the length of the median is half of the length of the hypotenuse. That is, we have BD is equal to half of AC, as AC is the hypotenuse. And the reason is median drawn on the hypotenuse. So we have the length of hypotenuse AC, that is given to be 15. So we'll replace AC here by 15 to get BD is equal to half of 15. If we divide 15 by 2, we get 7.5. So this is the length of segment BD, that is the length of median of its hypotenuse is 7.5 units. Let us have the next question. This is the diagram given in which triangle PQR is given. Now in this diagram, it is given that point G is the point of concurrence of medians of triangle PQR. That means here segment PT, and along with segment PT we have another two segments which are medians of triangle PQR, and point G is a point of concurrence, that is these three medians are intersecting each other at point G. That's why it is called as a point of concurrence of three medians of triangle PQR. Length of segment GT is given to be 2.5, and from this we have to find the length of segment PG and the length of segment PT. Now as it is given that point G is the point of concurrence, as G is the point of concurrence of the medians of triangle PQR, where segment PT is one of the medians of triangle PQR. And as G is a point of concurrence of medians, it is called as the centroid of a triangle. Because point of concurrence of three medians of a triangle is called as the centroid of a triangle. And we have one property of centroid, that is centroid of a triangle intersect each median of a triangle in the ratio 2:1. Now as here G is the centroid, this point G intersects segment PT, which is the median of triangle PQR, intersects in the ratio 2:1. That's why point G intersects the median PT in the ratio 2:1. Here if we take the ratio of PG and GT, that is PG is to GT is equal to 2:1. That means if GT is 1 unit, then PG must be its double. So we have the relation between GT and PG. That means GT must be half of PG. Now here the length of GT is given 2.5. We'll replace GT by 2.5 is equal to 1/2 into PG. If we take 1/2 to the left hand side, it will be in the numerator. That is to get 2.5 into 2, that's 5 is equal to PG. That means PG is equal to 5. So this is the length of first segment we wanted. That's PG is equal to 5 units. Now we have to find the length of segment PT. As we can observe, PT is the sum of two smaller segments, PG and GT. We can write here PT is equal to PG plus GT, where PG we have found to be 5 plus GT it's given to be 2.5. So PT is equal to 5 plus 2.5, that's 7.5. So this is the length of segment